In this video, we will solve a reaction stoichiometry fractional conversion / limiting reactant problem. And so if you want, you can pause the video here and attempt the problem. So let's get started. So we have a fractional conversion of 25% of the limiting reactant is achieved. And we want to determine what is the limiting reactant, and we want to know the percentage by which each of the other reactants is in excess and the molar amounts of all the product gas. So first thing we're going to do is know how much moles is each component going in. So we have NC3H6, and we have 200 times 0.1, so that's going to give us 20 moles. Then we have NH3, and so 200 times 0.15 is going to give us 30 moles going in. And then N oxygen, so 200 times 0.75 times 0.21 is going to give us 31.5 moles. And if you notice in this reaction here, there's no nitrogen and there's no nitrogen. So nitrogen is an inert gas. And so for this part of the problem, we will not need to use it. So now we need to know what is the limiting reactant. So we can do that next. To get the limiting reactant, so first we will say NH3 divided by this. NC3H6. And if we do that, we would get 30 divided by 20, and that's going to be 1.5. Now, next we will do the stoichiometric ratio of the two. So what actually would be the ideal situation? And so we can say that NH3 divided by NC3H6, and then stoic, or S, or whatever. And that's going to be 1 divided by 1. So you do the number in front. That would be the most ideal situation, because in a perfect situation, if you have 1 of this, and 1.5 of this, you would get exactly 1 of each. But typically, you can never really get a perfect situation like that, and that's why there will be things that are limiting. And so if we do that, we get 1 divided by 1. So 1 divided by 1 is equal to 1. And now with that said, we can see that in the real situation here, this is what we really have. We have 1.5. And in the ideal situation, we have 1. And if you notice in the numerator, we have NH3. That would mean that NH3 is excess. And next we will do oxygen, because if NH3 is excess of this, maybe this might be the limiting reactant, but we don't know yet until we try oxygen. So we can do oxygen, the exact same thing. So N oxygen divided by NC3H6, we get 31.5 divided by 20, and by doing that we get 1.575, and then we do the exact same thing with the stoic. So N oxygen divided by NC3H6 stoic, ST, and that would be, so oxygen is 1.5, 3/2, and this is still 1. So 1.5 divided by 1 is going to give us 1.5. Like this part, if you notice, so oxygen is on top divided by this, and if you notice this number right here, the actual situation is larger than the ideal situation of this reaction. That would mean that oxygen is in excess. Since NH3 and oxygen are both in excess, that would mean that C3H6 is the limiting reactant. So we can say that C3H6 is limiting reactant. So that's the first part of the problem. Next, we are going to want to know the percentage by which each of the other reactants are in axis. So how much percent is this in axis and this? So NH3 and oxygen. So we can do that next. So in order to do that, we need to know, in an ideal situation, how much moles of NH3 and how much moles of oxygen would we have if we're inputting 20 moles of C3H6. So let's do that. So we can say NH3, this is going to be the stoic, the ideal situation, is equal to 20 moles of C3H6, because C3H6 is the limiting reactant. So we want to know how much of NH3 would we get a perfect, this ratio. So we have 1 mole of C3H6. 1 mole of C3H6 would be 1 mole of NH3. 1 mole of NH3. So in an ideal situation, you would want 20 moles of NH3, not 30 moles. Likewise, we will do oxygen. So N oxygen, stoic, is going to give us, so you have 20 moles going in of C3H6. That's the limiting reactant. And we have 1 mole of C3H6. And then we have 1.5 moles of oxygen. And that's going to give us 30 moles of oxygen. That would be the ideal situation, not 31.5. And next we will do a calculation to determine the percent axis. So if you want, you can pause the video here and write down what we have, because I'm going to scroll down. And to get the percent axis, there's a formula for it. So it's going to be the regular, the number we got originally, minus the stoic, the ideal situation, divided by stoic times 100%. And so for NH3, we had, for the regular, what we first did, we got 30 minus the 20 for the stoic, divided by 20 times 100%, and that's going to give us 50% access NH3. So that's another answer that we needed. And then next we will do the exact same thing for oxygen. So regular was 31.5 minus 30 divided by 30 times 100, and that's going to give us 5% access oxygen. So now we have that. Next, it says that a fractional conversion of 25% of the limiting reactant is achieved. So by this statement, we will know how much C3H6 will be in the product end. So NC3H6 is equal to, so 1 minus 0.25, so 0.75, times the 20 that went in, the 20 moles that went in, and that's going to give us 15 moles of C3H6. So we have 15 moles C3H6 in the product side. Next, we can get the extent of the reaction. If going in was 20 and then coming out we had 15, that means we can say 20 minus 15, so we would get 5 for the extent of the reaction. So this can help us to get the other products like NH3, N oxygen, N C3H6N, N water, and N nitrogen. It's an inert gas, so equals. Now this is all the product. This is also the product. So let's go back to our reaction. So for NH3, we would say our going in 30 minus extent of the reaction. So minus 1 extent of the reaction. Next, oxygen. You would say going in was 31.5 minus 1.5 extent of the reaction. Next, C3H3N, that's just going to be 1 extent of the reaction since you have a 1 right here. And then water, so you have 3 in here, so it'll be 3 extent of the reaction. And so let's do that now. So nitrogen would be 30 minus extent of the reaction, which we said was 5 above. So that would be 25 moles of NH3. That's one answer. Then oxygen, we had 31.5 going in minus 1.5 extent of the reaction. And so that's going to give us 24 moles of oxygen. Then C3H6N, we had 1 extent of the reaction, so that's going to be 5 moles of C3H6N. And then water, we had 3 extent of the reaction, so that's going to be 15 moles of H2O. And finally, nitrogen, which is an inert, you pretty much go with your input. So let me show you again. So you go 200 times 0.75 times 0.79 because it doesn't react, so it's going to stay from the reactant and the product. So let's write that down. We had 200 times 0.75 times 0.79, and so we would ultimately get 118.5 moles of nitrogen. And that's all you need to do for this problem.